Hello, my name is Pranav Barkar, and in this video I will walk you through my analysis of the Calgary web server logs using the Jupyter Notebook. So firstly, I installed the required packages and import the necessary libraries such as gzip, regular expression and pandas to process the log file. I created a function to download the .gz compressed dataset from the FTP server with proper error handling. Then using a regular expression, I parse each log line to extract fields such as the IP address, timestamp, request type, status code, and bytes. I also converted the timestamp to determine the objects, extracted the file extension, and safely handling the missing malform entries by skipping them. Finally, I read the compressed file line by line, parsed the valid records, and loaded them into a pandas data frame. I then printed the structure and a sample of the data using info function and the head function to verify data quality and types. This step ensures our data set is clean, well structured, and ready for further analysis. So uh, that's the outcome of the code that I used for analyzing the data set. So here I get all the necessary information that required for this project. I get the host, data time, method, file name, extension, and status from the dataset. Now let's begin by running this or executing all the cells step by step. So in the first cell, we have to count the total log records in the dataset. So here I simply written the length of the dataset as each row correspond to one log entry. Then the next cell, to understand the diversity of visitors, the code counts here. Here the code counts the number of unique hosts by finding the distinct values in the host column. So here I simply return the host with n unique function. So in the next question, we have to find out the date wise unique file name. So here I simply use pandas and regular expression to find out the unique date wise file name. So for analyzing the daily activity, the timestamps are converted into a consistent date format, allowing grouping of records by date to count how many unique file names were accessed each day. So that's why I use that df logs file and find out the result. Here is a output of this question. Next, in this we have to find out the number of 404 response codes. So in this cell, we need to count how many times the http 404 error appears in the data set. So I added the logic that filters the data frame to include only rows where the status code is 404. Then using shape it returns the total number of such rows, effectively counting all 404 errors in the logs. In the next cell we have to find the top 15 requested file names that resulted in a 404 errors. So I have to first filter the dataset to include only rows with the status code of 404. Then it counts how often each file name appears in this filter row using the value counts function, and then select the top 15 using the head function, and finally convert the result into the list of tuples. This helps identify which missing files are being requested most frequently and get the answer. So in the next cell, analyze which file extensions most frequently resulted in 404 errors. So for this, I filter the data set to only include rows where the status is 404. It then count the frequency of each file extension in this errors entries using the value counts using the value count function, and then select the top 15 with head function and convert them into a list of tuples. This helps identify which type of missing files like .html are most commonly requested but not found. So now let's move to the next cell. Here we have to find out the total bandwidth transferred per day for the month of July 1995. So in this cell I calculate the total bandwidth in bytes transferred each day during July 1995. Here I filter the dataset to include only entries from July 1995 using the date time column. It then groups these entries by the formatted date strings and then sum the bytes column for each day. So as a result, it converted to a dictionary mapping each day and to the total bytes transferred, helping to visualize daily traffic volume during that month. So here I get the answer as required. Now let's move to the next question. In this cell I compute the distribution of HTTP requests across each hour of the day. So I extract the hour from each timestamp in the date time column and creates a new hour column. It then count the number of requests per hour using the value count function. So this will help to identify peak traffic times throughout the day. So in the next cell we have to determine the top 10 most requested file names. So here I count how many times each file name appears in the dataset using the value count function. So it then select the top 10 entries with head function and convert the result into a list of tuple. This helps to identify the most accessed resource on the server. Next question is to find out the HTTP response code distribution. So in this cell I calculate how frequently each HTTP status code appears in the log data. So here I use the value count function on the status column to count the occurrence of each response code. It then converts the result into dictionary using toDict function. This helps in understanding the distribution of successful responses, client errors like 404 and server errors across the logs. So after executing this code we get this answer. And finally, during the log analysis project, I faced challenges related to the volume and variability of log data. The log contained inconsistencies and occasional corrupted entries, which required careful parsing and validation to ensure the accuracy. Despite these challenges, the project successfully identifies critical insights such as the total number of 404 errors, which highlight potential issues in our web infrastructure. This analysis provides actionable information to improve user experience by addressing missing resources. Moving forward, automating this process will enable continuous monitoring and quicker response to web errors, supporting overall system reliability and customer satisfaction. So that's it about the project. Thank you.